So here we have two examples just to get us a little more familiar with the derivative. Part A says find f of x and f prime of x if the derivative is the limit as x goes to 1 of the quantity x to the 100 minus 1 over x minus 1. Well, what we see here is the limit definition of the derivative, and you might recall that that is given by f prime of a, so this is the derivative at a specific point a, equals the limit as x goes to a of x minus f of a all over x minus a. So this is the x minus a version of the derivative versus the h version of the derivative. Right? You want to be able to recognize both versions of this thing. Okay, so then what I'm seeing here is that this must be my f of x, right? Because it matches f of x. X goes to 1, so that's telling us x goes to a, so that tells us that 1 must be our a. So we've already identified f of x, so we can do part of this. All right, we've already decided that f of x must be x to the 100. That just jumps out once you recognize that this is the limit definition of the derivative. And then it asks us to find f prime of x. Well, at this point, I'm going to leave this limit definition of the derivative behind because we don't need it anymore because we have the power rule. And I certainly don't want to worry about factoring x to the 100 minus 1, though we could do it. It's not the end of the world. But instead, I'm just going to use the power rule. The power rule, of course, tells us to take the exponent. When we take the derivative, we take the exponent down to the front and subtract 1, which is a very inviting thing to do for something like f of x equals x to the 100. Because we can quickly say f prime of x then equals 100, I brought it down, x to the 100 minus 1 to the 99. And there is the derivative. And just in case we want the derivative at the point 1, we can evaluate this thing at 1 by just taking f prime of 1. So sometimes we want the derivative at an actual point, so the way you approach that is you find the general derivative in terms of x, and then you just plug in whatever you want for x, plug that into the derivative. Okay, so I'm going to plug in 1 here, and that would give us 100 times 1 is 100. Okay, so we're just playing around with derivatives a little bit here. Part B says if f of x equals 3x cubed plus 5x squared plus 6x, find f triple prime of x. I'm actually going to go even further than that. I'm going to go all the way down to the fourth derivative. So triple prime, of course, is the third derivative. So let's do it, right? We're just going to use the power rule along with technically the sum rule and the constant multiple rule, but those kind of get folded into the power rule. Okay, let's just start taking derivatives. We have f prime of x. We're just hitting this thing with the power rule. 9x squared plus 10x plus 6. All right, from there we can go to f double prime of x. So now we're taking the derivative of the derivative. We call this the second derivative. All right, power rule again. 18x plus 10. Right, the 6 drops out because the derivative of a constant is 0. Okay, let's scroll a little bit, clear out some room. F triple prime of x, prime, prime, prime. Now we're taking the derivative of the second derivative. So power rule just gives us 18. We're running out of stuff. And f, once we get to the fourth derivative, we don't write prime, 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 prime. We write this, 4 in parentheses like this. So the fourth derivative of x, look at that, is 0. So sometimes you can think of the derivative as kind of a smoothing function. The more derivatives you take, you kind of smooth out a polynomial until eventually you get nothing left, just a horizontal line. Okay, so we'll have plenty of opportunities to take second and third and fourth derivatives in this course. And it's nice to get a little bit of exposure, at least to the concept here.